Hello students, welcome to your final class on compound interest. In the last class we dealt with sums related to compound interest. After understanding what compound interest actually are, how to use it, how banks use it, we also looked at simple interest and their applications, how compound interest is different from simple interest, and we did a lot of things. In today's class, we will tackle a variety of questions related to compound interest. We'll tackle sums on finding the amount and the compound interest where the rates are different, the time periods are different. We'll look at some advanced questions, we'll learn some short tricks, and we'll proceed further. So, without further ado, let's begin the class. So, in the last class, we first learnt about simple interest where a sum of P was kept in a bank at a rate of interest R for T years, and that gave me an interest of P into R into T by 100, right? This was a simple interest. Whereas the same sum when kept at a compound interest, so this amount, the sum P is kept at a compound interest at R percentage for T years, that basically gave me a compound interest of this amount, okay? So in today's class, we'll use these formulas, we'll understand the working of these formulas and we'll proceed further. So let us look at the first question. In the first question, it is asked to find the compound interest and the amount. So basically we did this sum on the last class where the amount and the compound interest were asked, but there is a catch in this question. So here the principal amount was 16,000 rupees, right? And the rate was 10% per annum, right? Till here it is fine. Now the time period here is kept for 1.5 years, right? Okay, the rate is 10% per annum, that is compounded yearly, and the time period is 1.5 years, correct? Now it is given in the question that the interest is compounded half yearly, right? Now what does this mean? Interest is compounded half yearly. This basically means that every 6 months you get the interest amount, okay? So in that case, what the changes will be in the question, let us first look into this, okay? So the principal is 16,000, okay? Now the time is basically 1.5 years. So let's first convert the time into unit, that is basically the compoundation rate, okay? So 1.5 years is basically 12 months and 6 months, that is 18 months, right? Now in this 18 months span, how many times we will be compounded a interest, okay? So you will get interest 3 times, okay? First 6 months, then again 6 months, and then again 6 months. So you get the interest 3 times, okay? So just consider the time period to be 3. So your interest is 3 times, okay? Now the rate is 10% per annum, right? So once a year is complete, you get 10% interest for that year, okay? But now the interest is being compounded half yearly, so the interest has to be made after 6 months. So we need to convert this rate so as it satisfies the 6 months criteria, okay? So 1 year is 12 months and we just need 6 months. So convert this, right? So it becomes 5% half yearly, okay? So the rate is 5%, the time period is 3, and the amount is 16,000, okay? So basically finding the amount now is reduced to this formula. Amount is principal times 1 plus R by 100 power of T. Here the T is 3, okay? Now solving this, you get 16,000 into 1.05 to the power 3, which results in 18,522, correct? Okay, so this is your amount. Now once you have got your amount, just subtract it from the principal and you'll get the compound interest. So 18,522 minus 16,000, that basically gives you 2,522, correct? Okay, that's your answer. So this is how you tackle the question. So when your time period is given in not whole number of years and your interest is also not computed yearly, just convert them into your asked rate, okay? convert time into the given number of interest compoundations and convert the years as well. Okay, then you get your answer. This is a simple sum. Now let us look into a different kind of sum. Now this kind of sum is also very common when your exams are concerned. Now here let us suppose that the principal is 37,500, right, and it is invested for 2 years. Okay, it is invested for 2 years at successive rates. R is 8% and R is 9%. Okay, now you need to find the amount. So you see that the rate of interests are no longer the same. Okay, sorry guys for the issue. Yeah, so I was saying that the principal is 37,500. It is invested for 2 years and the rate of the first year is 8% and the rate of the second year is 9%. So the rates are different for 2 different years and you need to find the total amount. So in this case what you do is there are 2 different methods. Okay, so the first method is the conventional method where you just calculate the interest for the first year, then you have the amount that becomes your principal for the second year, and then you calculate the amount once again. Okay, that's the conventional method. Okay, but we are not satisfied with conventional method, right? So as far your exams are concerned, please do it in the conventional method because that's what your universities want. So your schools want, sorry. So you have your principal, you calculate the amount for the first year, that becomes your principal for the second year. Now again you have the principal and you calculate the amount, that becomes your final amount, right? You can do this using the formula, but I want to teach you guys a better method. So you have a principal, you have 2 rates of interest, so 1 plus r by 100, and on this is the amount resulted after the first year. So on that you calculate the amount for the second year as well. So what you do is just do this, r2 by 100, right? So when you're given subsequent rates, just use this. If you had been given for 3 years, just you have to do this, r1 by 100, 1 plus r2 by 100, 1 plus r3 by 100. That's where the derivation also came from, guys. And also when you have the rates of interest equal, that basically results in this power, right? So do it this way. So you have 37,500 and you have for 2 years. For the first year you have 1 plus 8 by 100, that's the rate, and for the second year you have 1 plus 9 by 100, right? So after calculation this basically amounts to 44,145. Please check with your calculators, right? Okay, so that is the amount, right? So whenever you given alternative rates, you are given subsequent rates, just use this formula. This is actually from where the equation was derived. Okay, now let us look at the next question. Now in this question, this is also a common category of questions. You are asked to find the difference between the compound interest and the simple interest on a principal amount of 5,000 rupees that has been invested for 2 years at the rate of 8% per annum. Okay, so you need to find the difference. Obviously you know that the compound interest will be greater than the simple interest, right? Because simple interest is calculated on the same sum, whereas the compound interest is calculated on the amount as well. Okay, so this will be greater, but you need to find the difference, and in order to do that quickly, we'll look at a short trick after we look at the conventional method. Okay, so first let us look at the conventional method. So calculate the simple interest, which is fairly simple, 5,000 into 8 into 2 by 100. So this results in, you cancel off this results in 800. Okay, now the compound interest is basically the principal 5,000 times 1 plus 8 by 100 to the power 2 minus 5,000, right? This is basically 5,000 into 1.08 squared minus 5,000. Taking 5,000 common, you have 5,000 times 1.08 square minus 1, right? So this is fairly simple. All you need to do is calculate this, and this finally results in 832. So you get a difference of 32. So the compound interest is 832, and the simple interest is 800. So the difference is 32. This is your answer. Now this compound interest, you calculated this, you have to basically multiply this 2 times, right? So this was a hectic job. Now if it had been 4 years or 5 years, it would have made your life more miserable, right? So in this case, there's a shortcut, right? So this is actually known as the AB method. What is the AB method? So see, the interest on the first year A is 8. Also on the second year is also 8. Correct? What AB method does is it finds the actual rate of interest both combined. Okay, so you have this for 2 years. So on having the AB method, it will give you a final rate of interest R, and you need to consider the number of years as one. So this gives you what sum? The same sum will be given by R when kept for 1 year. So what I mean is, I'll show you by the example. So you have this. So AB method basically tells you that the resultant would be A plus B plus AB by 100. Now just plug in the values. This is the formula. Just plug in the values. So that's 8 plus 8 is 16, and you have 64 by 100. So you have 16.64%. So the amount 5000 when kept at 16.64% at 1 year will give you the same result as 5000 rupees kept at 8% interest for 2 years, right? And 5000 kept at 8% simple interest for 2 years will be basically equal to 5000 at 16% for 1 year, right? Because this is simple interest, and you calculate the compound interest using the AB method, right? So the difference is interest is 0.64%. So 0.64% is basically the difference in the compound interest and the simple interest, right? So what you do is just use this 0.64 and do it on this sum, right? You don't need anything else, correct? You have this, you have the simple interest, just do this, okay? So 0.64 into 5000, that will result in 32 as well, right? You can check in with your calculators. So you didn't need to do rigorous calculations. So this was 8% for 2 years simple interest, that is basically 16%, right? 8% for 2 years at compound interest, that was 16.64%. The difference is 0.64%. 0.64% of 5000, that is basically 32. Sum solved in 3 lines, okay? But do not use it in your board exams, use it in your competitive exams where fast calculations are required, or in your MCQs where they just care about the answer and not the method. So you can use this, okay? But as far as your board exams are concerned, always use the conventional method, because that is also important, okay? Okay. Let us look at some more questions, probably this other type. Okay, so now this is a type of question which is very tricky, and it is difficult to understand because it is against your intuition, right? So let me read out the question first. So this is the amount to 20,000 is lent for a year at 12% per annum, right? It is lent for a year at 12% per annum. Now, what will be the difference when it is lent for 12% per annum compounded half yearly, right? Now you might say that, sir, this was 12% and the time was 1 year. Now you are basically telling me to have the rate as 6% and the time is 2. What difference would that make? Will it make any difference? See, for simple interest, it won't make a difference. But for compound interest, let us check. Right? For the compound interest, let us check. So, 20,000, the simple interest. Okay, so calculate the compound interest. So, the compound interest for the first year, compound interest and the simple interest is basically the same thing. So, you can very well calculate the simple interest. That is basically 20,000 into 12 into 1 by 100 results in 2400, right? Now calculate the CI dash when 20,000 is kept for 6% half yearly and it's kept for 1 year. Okay, so this will basically give you 20,000 times 1.06 power squared minus 1. Okay, so this is your compound interest. So this basically amounts to 2,470. Now you see that it is kept for 1 year at 12% and it is kept for 1 year at 12% compounded half yearly. So this, you're getting interest 2 times and you're getting interest 1 time, the same interest, that makes a difference, right? Because in compound interest the rate is a linear variation. So you have 1 plus r by 100, but the time is quadratic variation. So you have this power t, right? So if this is 1, no matter what it be, so this is 1.12, but when the rate is 1.06 and this squared is basically greater than this, right? So this is where, do not be mistaken or do not be tricked by this kind of sums. Always remember that when you break into more intervals and you receive interest more number of times, it will obviously result in a greater value. Okay, obviously sometimes they do not even ask the question where it's the difference. They will tell you that uh, it is lent for 12% per annum and it is lent for 12% per annum compounded half yearly. So comment on the amounts, right? So they will give you A1 equal to A2, A1 greater than A2, A1 less than A2. So suppose this A1 is corresponding to compoundation of 1 year and this is A2 compounded half yearly. So obviously A2 will be greater than A1. Never even go with the equal case. Always eliminate the equal case. Okay, that's the kind of sum. So let us also verify by the AV method. So 12% per annum for 1 year is basically 12% rate. Okay, but 6% half yearly, right? So A is 6, B is 6. So 6 plus 6 plus 36 by 100. So you have 12.36%. So 0.36% of 20,000 is the difference. So 36 by 100 into this, right? Okay, 0.36%, right? So yeah, this. So basically that is 72, right? You got your answer. Okay, fine. So these kind of questions are very tricky and students actually fall for this trick. Okay, let's do one more problem, and this problem will, with this problem will end this chapter and also the today's class. So now see, it is given that SI and CI on a sum, they didn't mention the principal, on a sum at 5% per annum rate is equal, right? Now they are telling you to find the time period. Find the time period. Okay, so you basically need to find out the time period for which simple interest equal to compound interest. Now it is our intuition that for the first year the simple interest and the compound interest will be same. But when you are given this kind of a question, you actually need to prove this thing. Okay, so you are given a sum. The sum is not mentioned. Consider to be P, and the rate is 5 and the time is, consider that to be T because you need to find the time. Okay, this by 100, and the compound interest is basically P times 1 plus 5 by 100 power T minus 1, right? Okay, so cancel off the P's. So 5T by 100 plus 1 will be 1 plus 5 by 100 power T, right? So now this is your equation. You need to satisfy this equation. Okay, so you will get two answers for this equation. Let me show you how. So start off with the minimum values. So let us start off with 0, 1, 2 and let us go on and carry out. Okay, so take t equal to 0. The the LHS becomes 1 and the RHS becomes 1 plus 5 by 100 power 0, that is also equal to 1. SI equal to CI. Is this your answer? Is this your answer? No, right? T equal to 0 actually means that you didn't invest the money at all. Okay, so do not fall for this trap. This is the only trap here. Okay, next use T equal to 1. So for T equal to 1, this is 1 plus 5 by 100. Also, this is 1 plus 5 by 100. So, is this true? Yes. When it is invested for 1 year, the simple interest and the compound interest actually gives you the same result. Okay. Now take T equal to 2. So this becomes 1 plus 10 by 100, whereas this becomes 1.05 square. Now, from here, this will always be greater. The RHS term will be always greater than this. Okay, because this is basically CI, this is basically SI. Right? CI will always be equal to greater than SI for more than a year. Okay, so now you can confer that the time period is either 0 or 1. So if you do not invest, the CI and the SI both are zeros and they are equal. And if you invest, then the CI and the SI for the first year is always same, right? So this is your answer. So these are the trick questions that can come. You need to practice more sums on this type. Basically, these are all the types that are possible. There is no other sum from compound interest that can trick you. The rest of the sums are basically very simple, fairly simple to do, and to actually they're intuitive. Okay, so practice more sums like this. Do it from your whichever book you are following, and I hope that you will be able to tackle this chapter very well. Okay, thank you. I hope you guys had fun. Meet you in the next class.